So, welcome to today's NFDI talk about the NFDI for Data Science Gateway and Portal. Welcome to our two speakers, Rana Muhammad Abdullah from Leuphana University and Sonja Schimmler from Fraunhofer FOKUS and the TU Berlin. So, a short introduction of our of today's speakers. Rana Abdullah is currently affiliated with the AIX Lab at Leuphana University, which focuses on hybrid AI methodologies that integrate subsymbolic machine learning with symbolic knowledge representation via knowledge graphs to develop transparent and explainable AI systems. In parallel, he works as a data scientist at WebNets, applying advanced AI techniques in real-world scenarios. In alignment with the AIX Lab's vision, he has been actively involved in the development of the NFDI4DS Gateway. So welcome. And our second speaker, Sonja Schimmler, is a visiting professor for research data infrastructure at the Technical University of Berlin, and she also leads a research group at Fraunhofer FOKUS. She's involved in numerous third-party funded projects and plays a key role in the National Research Data Infrastructure, NFDI. She serves as a spokesperson for the NFDI4DS Consortium and the Common Infrastructure section, as well as a co-spokesperson of both the NFDI a Base for NFDI initiative and the NFDI for CAT consortium. Additionally, she is active in the Berlin University Alliance and the Weizenbaum Institute, so many roles. Welcome, Sonja, and I will hand over to you too.
Yeah, thanks for the introduction. Let me share my slides. Okay, good. Yes, today Rana and I are going to give you a presentation, and actually we're going to focus on the NFDI4DS Gateway and Portal, actually two systems we developed in the last few years. Before I start off with the presentation, I will give a very brief overview of NFDI for data science. So no worries, not very long, but just to get us started. So NFDI4DS is actually the National Research Data Infrastructure for Data Science and Artificial Intelligence. So please don't forget this addition, artificial intelligence, please don't forget that. And what our vision is, as many consortia, we target the data science and AI community in Germany, and we support the whole research data lifecycle from collection, creation, over processing, analysis, preservation, access, and reuse. And our objectives are, on the one hand side, of course, we want to build a research data infrastructure, but what might maybe make us a bit special is that we are handling all digital artifacts, so not only articles and data, but also models, workflows, scripts, and code. And what is also very important for us, which is a key thing we're doing in the consortium, is we want to interlink all those digital artifacts. And what we're internally actually using a lot, on the one hand side, to represent digital artifacts, here we are using fair digital objects, and on the other side, to interlink them, we use knowledge graphs. And what we also do, as many other consortia do, we foster fair and open research. And what we really want to move forward with is we want to increase transparency and reproducibility of research. And what we are usually doing, or where we did dive in a lot in the last few years, is also we consider ethical and legal and social aspects. So that was kind of the vision of NFDI for data science as we started. And what changed in the last 2-3 years was actually the hype of generative AI. And we asked, in this endeavor, we asked the different questions. So in general about generative AI, we asked, is there a difference in the use of LLMs in the different communities? And how can we support researchers and the general public that use LLMs? We asked it from a perspective of data infrastructures. We asked ourselves how we can adapt infrastructures to support researchers that use LLMs. And we asked ourselves from the perspective of data competencies, where we asked what new competencies are needed by researchers that use LLMs. And Overall speaking, so how do we consider AI? On the one hand side, we consider it in a way, I really like that, data infrastructures for AI and AI for data infrastructures. And our sharpened vision, I would say, is now we want to have AI assistance in the whole AI research lifecycle. And when you look on this visualization, it's a very, very high level visualization. We are building different infrastructures. So the backbone is on the one hand side our compute infrastructure and our research knowledge graphs. And then we have our different tools and services. We have different registries and repositories. And at the uppermost level, we have our NFDI4DS Gateway and Portal. And that's actually what we are talking about today. As I already mentioned, and which is also very important for our gateway and portal, we are not only integrating publications and data, but also other digital artifacts ranging from models, workflows, and code. And we're thinking about how to integrate them, how to connect them, how to represent them. So that's for us very, very important. When you look at those two systems, on the one hand side, you can see on the left, you can see our prototype of the NFDI4DS Gateway. The scope is, so we're integrating resources from worldwide and to serve our data science and AI community. The approach is we are gathering this information, the metadata on the fly, and allow for a full-fledged search throughout this metadata. We have some fancy special features in there. One example is a chatbot, but there are other nice ones you will see in a minute. And the metadata schema that it is based on is schema.org. You can try it out, check it, but be aware it's a prototype and we are still working on it, and we are integrating very many fancy different tools and services in the system. The other service we are providing is the NFDI4DS Portal. It serves a similar endeavor, but it's a little different in a way that in the NFDI4DS Portal, our scope is NFDI. So what we are integrating is all the different NFDI resources, so the different NFDI communities on different platforms like GitHub, and also the different NFDI repositories that are provided. The approach is also different in a sense that we are harvesting the metadata, which allows us, besides searching for different artifacts, you can also explore it, browse through lists. And it also has some special features like a metadata quality check, which you will also see in a minute. It's also based on a metadata standard. In that case, we are basing it on a the DCAT-AP standard. Okay, that's it for now for a general overview. And now I'm going to dive into the NFDI4DS portal, and afterwards Rana is going to dive into the NFDI4DS Gateway. So looking into the NFDI4DS portal, I already showed you this visualization. As you can see, we have this portal which integrates different resources. And I can show you a few examples on the next slide. So on the one hand side, we are integrating different general purpose repositories, and there we usually harvest the community of the NFDI consortia. So for example, what we did is we harvested the NFDI4DS Zenodo community, the MADI GitHub community, or the general NFDI YouTube community. On the other side, we have integrated different domain-specific repositories, so repositories from NFDI consortia, and two examples of those are the Fermat Nomad repository and the NFDI4Chem Radar4Chem repository. And on the bottom, you see a few examples. You see the MADI GitHub community, the NFDI YouTube community, and the NFDI4Chem Radar4Chem repository. And we've integrated several of those repositories for now as a proof of concept, and in the next few months we plan to include more and more to kind of have the whole NFDI covered in this meta portal. When looking at the portal and its architecture, the Meta portal is actually based on Pivot. It's a data management ecosystem that is, for instance, also used in Data Europa EU. And on the right-hand side, you see this overall architecture we have. It has three base components. The first component is Pivot Consus, which is there to harvest the data. It's quite flexible. We already have many different importers in place. So if you want to integrate something new, that's pretty easy. As a second component, we have the Pivot Hub component that's actually responsible there for the storage consisting of a registry, indexing, and translation. And as a third thing, I will also show some examples later on, is our Pivot Metrics service, which is there to check the quality of the metadata that is integrated. And as you can see on the left-hand side, okay, of course, there are the different data sources and they are fed into the system and used, and internally it's stored in a triple store, and there are some additional stores to make life a bit easier. So when you look at it, here are two examples. The first example is NFDI YouTube. At the left-hand side, you see an overview of what is actually in there. So at the moment, there are almost 200 videos that can be found on this page, and there you have an overview. As you can see, for the roadshow, there's no description provided on YouTube. I also checked that. And on the right-hand side, I did dive in one of the last NFDI talks on the 19th of May, which is available on YouTube, and there you see what is all integrated in the portal and what you can see in there and what you can browse. I also brought you a second example. I actually brought it from Madi GitHub, the community, and on the left-hand side again, you see an overview of the resources that are available in there, and on the right-hand side, that's why I chose this example, you also see different distributions of one of the repositories there, in this case from Portal Compose. So what you see there and what it is actually based on, so the metadata standard that is in the back of the NFDI4DS portal, it's DCAT AP. So this is the standard that is tailored to the European Union. And on the right-hand side, you see this overview graphic. You can see there are different types in there, and the main types are actually a catalog, a data set, and a distribution to model catalogs and data sets there. And as an example, how it's represented, for instance, a catalog could be the NFDI Zenodo community, a data set could be the section infra concept, and the distribution could be the concept version. And what you see on the right-hand side are those different types and also the different attributes you have. Some are mandatory, some are recommended, and some are optional. And what is actually done if we implement a new harvester, it's pretty much that we need to define a mapping, and here are some excerpts provided for Zenodo, GitHub, GitLab, and YouTube, and also the DCAT properties for the data set and the distribution. So you usually have to find those mappings and provide it, and that's more or less it. If you want to integrate a new repository, then you have to define that, and then more or less you're done and can do that. Of course, it's a little bit more, but in essence, that's what's actually happening. As we are based on DCAT, what our Meta portal also provides, on the one hand side, we have a Sparkle endpoint, and I just entered as I entered a query earlier today, which you can see on the right-hand side. So what I did there as an example is I retrieved the 10 last modified data sets, where you can also find on the right-hand side. So you really have a fully fledged way to access the metadata that is harvested and stored in the portal like that. And as a second thing, what we have as a special feature, and there we are heavily working on at the moment. We have a metrics service where we actually assess the metadata quality of the integrated resources, the integrated metadata, and it's actually assessed based on the FAIR and on the 5-star principles. So we have the categories findable, accessible, interpretable, and usable, and we also added contextuality. And on the left-hand side, I showed you a few screenshots of our portal, where you can also see the findability and the accessibility. In that case, I opened the assessment of the Zenodo NFDI4DS community, that you can have an example and see that. And what we actually plan to do in the portal, so it's still work in progress. On the one hand side, we plan to integrate further resources, but on the other side, we also plan to extend the metadata to domain-specific metadata on the one hand side in the portal itself, but also with regards to this quality assessment for service. And of course, if you check the service out, it's still a prototype. We are heavily working on it, and hopefully we have a really functioning version in about 1 year. And that's it from my side. And I would now like to hand over to Rana to give us some insights into the NFDI4DS Gateway.
It's shared now, right? I'm audible, yes. Thank you. Thank you, Sonia. Regarding the NFDI gateway, it's basically another service which is developed under NFDI for DS. As majority of the things already been briefed by Sonia. I would say the core idea behind this initiative was to enhance the fair usage of research data. As the data is continuously growing and it's heterogeneous and it's already fragmented, and our goal was to actually enable the researchers access to this particular data. We did not limit the scope as it's worldwide. So and secondly, in comparison to the other repositories which are out there and the search engines, we don't maintain any of these repositories or the metadata. We do everything on the fly. We hit all these external repositories, we get the data, we parse it, process it, and then show the result as it's seen on the screen to the user. Another thing which is there is basically to facilitate the user to interact with those search results through a chatbot. We will see how the chatbot works. It's not fancy. Definitely, we should acknowledge this, because there is so much advancement done in the chatbot domain. But then still, the functionality is there and it works. And we should basically feel no harm in presenting this basically. But then we will see. And second one was, as I said, we are doing this federated search and I'm pulling the data from these disparate heterogeneous data sources. So the need was to basically harmonize this data, and we are using this very commonly used schema.org vocabulary taxonomy. We harmonize or unify the data from all these disparate sources, and then we process it once the harmonization is done. On the right side, we can see these multiple repositories which are actually parse or we pull the data from. Now, this is the landing page of the gateway. It's a simple, plain, just like the Google concept. There's a text box. You basically start by entering the key term, and then that's it, and then you start getting the results. But at the back end, there are so many things which are happening. We'll definitely dig deeper and then see how that pipeline looks like. In the second block, we see the data sources, which when the user click search. So all these data sources simultaneously being hit, and we get the data from all these sources. So currently there are 11 active sources. As and when new source is added, this is dynamically loaded into this block so that user would know how many data sources would be hit. And then, for example, there is any data source which is basically, so to speak, paused for any maintenances or something, then that will not be shown here for the period it's actually down. And in the third block, we can see the partners who are actually we are collaborating with for the active development of this platform. Once the user clicks on the search button, the results are actually shown into this kind of a format. Unlike Google, but then something similar to Google, where they actually categorize them into images, videos, and other search results. We in the scholarly domain, we thought of categorizing them into these buckets, and those could be basically publications. Researchers are individual persons who are basically the authors of those publications, or of something similar, basically the creative work. Then in the resources, we basically club all the models, data sets, or software applications. Those are basically parked into resources tab. Organizations are basically the companies, basically, if somebody is looking for something. Then events are the conferences or hackathons, or if which are happening in this particular domain. Projects are basically funded and non-funded projects, so that if a person is if as a user, if I'm looking for a person, then I should know if he is involved into certain projects. So this actually becomes a very good information. Then anything which is actually not, we basically this particular system gateway is not able to identify or classify, then those things are actually parked into the last bucket, which is others or miscellaneous. Now, of course, on the surface, it's quite simple, but then if we see the pipeline, there are so many things which are happening on the background, which I like, as we said in the first or the second slide. All these things are happening on the fly, and we don't maintain any repositories. So it's not directly pull the data and then show it onto the screen. So the way it's being done is all these data sources are simultaneously hit through their APIs, and as these are different data sources, so their taxonomies are also different. So once we get the data, so the immediate thing which is required to be done is do the mapping. So we do the harmonization using the schema.org mapping. We unify that data and prepare it for further processing. So once the unification is done, then the data is aggregated into those 7 buckets, which I showed you on the previous screen. And after that, we try to perform entity resolution, dedupe, so that, for example, if there is any one digital object, any publication or a researcher, if that particular record is being pulled up from 2 or 3 data repositories, then it should be deduplicated, and then person should be able to see one record. Of course, we used this dedupe library, but then the final output is still not perfect. So we are actually exploring other techniques. One such technique we are trying to implement is using graphs, and try to figure out if nodes and edges are basically overlapped. And if there is an overlap, there's a high probability those particular objects would be representing the same thing. And then that's how we can figure out the deduplication and then remove them from the search results. But then we're actually working on this, and we will see how far we can reach with this particular technique. Once the deduplication is done, then we perform basically similarity measurement using BM25 algorithm, and then we sort the results based on the similarity from the key term. On the top, we see different services which are being developed or implemented through our partners as and when they will be ready. So we're gonna implement them into the gateway as an extended service. Now, if we see on the top, there was a login functionality also, as we see from the green button over here. If my mouse is visible, I don't know, but then so we are basically empowering our users to narrow down their search. So if for a certain purpose, if a person is interested in a very domain specific data sets or repository, something, they can only focus on maybe something. For example, if they're related to social media, social sciences, then they solely focus on GISs. So this basically feature enables the users to narrow down their search and focus on the key aspects which they are interested in. So this will it has got the scientific benefit also, and then this also has the capability of fine-grained search results. Then one of the things which we have talked about is this unification or harmonization of the data. So we are using schema.org. It basically has this standardization of the attributes and the types different objects should have. For example, it has this hierarchical structure where certain things, attributes are tagged to a thing, and all these organization, person, event, and creative work, they are actually inherited from thing. So they have got their own attributes, and for sure the attributes which belongs to thing, they will definitely be inherited to these particular types. And then they have got these further types. An author would be a person, and same way an article would be a creative work. An image object will be definitely a media object, and media object is a creative work, something. So all these types, the more we dig deeper, it enriches its attributes, but then they are standard across all these types which are defined in schema.org. So we map all these search results which we get from these disparate or heterogeneous data sources, and then that's how we do the unification of the search results, and then we pre-process them for the further steps. The thing which we mentioned in the beginning was the bot implementation. So rather than having this regular search keyword thing and then using these regular filters, we thought of making it more interactive and giving the control to the user so that it can actually talk to the system and then dig deeper and find out more things about the search results which are there on the left side, basically. So we have implemented a bot. You can ask the questions, and then this will actually give you the very grounded responses, meaning it will not be an open-ended internet search which we are asking to the LLM, and then it's giving us a response which we believe can also be hallucinated. So we are saying the responses are grounded because the knowledge it is going to use to answer that particular question will be solely based on the knowledge base which consists of these search results, and nothing, no outside knowledge will be included into the response generation, basically. And the way it's being done is, as and when the search is completed, we create the embeddings in technical terms, but that's the knowledge base for that particular bot instance, for that interaction with the bot of the user. So the knowledge base would be created from those search results, and then the retriever component, it basically pulls out all these top K results, which are basically are basically pulled from this ensemble model, which consists of T, FIDF, SVM, and KNN. There are different ratios set for these models, and then once the results are output, then they are actually used by the generator along with the chat history and the question, and the response is generated and giving back to the user. And then, for example, from those search results, if the person is clicking on the publication details page, he'll see all these metadata related to that particular publication. It's a rich information, but then there are for sure important things like abstract, authors, and all those details, especially the citation and references, which are very common. But then besides this, if we see external links, for example, if one particular publication or digital objects is being pulled from multiple sources, so all those external links will also be shown so that user can actually navigate to those external sources and verify the information. Secondly, the Plummets matrix is also integrated, which actually gives the other things, like it's just not limited to citations only. And then the good thing about this particular plugin is it actually gives the information about the user, it captures mentions, and even the social media like sharings and all the, if something is actually being referenced in certain news articles or in news media, then those things are also captured in the mentions and those metrics, basically, which are actually reported by this. Besides this, we are also working on the integration of the fairness assessment service, which is actually developed by ZBW, our partners. And then once that particular thing is integrated, we will be able to see a score for this publication or a data set or any other digital object which we are viewing at. Along with this, if, for example, We're also integrating the Jupyter Labs into the gateway, which will enable the user to spin up another instance for the notebooks which are tagged to this particular publication. And then they'll be able to verify the results. The code would run for a certain amount of time, and then once it's executed, the person would be able to verify the results from the publications, the way it's published. Recommendations are actually pulled from Semantic Scholar, and the citations are also from the same source. Similar fashion, like the way we saw the publication details, a person can also click on the researcher's detail or other also, but then on the researcher's details, we generate the about section from all of the details which we pull related to that particular researcher. We're definitely looking at Sonja's profile at this time. I'm sorry, like why I pull this, but then yeah. So there are other basically other important information but related to that particular researcher, affiliations, publications, and the projects. They are also listed there, and then a person can easily navigate to that information and see. Just like the publication, all the external links are also be made available as part of the profile, and then research areas are also something important, which gives a granular view of the researcher expertise. A similar fashion in same way, like we have other detailed pages for the for the resources and other digital types which we have, but then it works on the same fashion. From the gateway perspective, that was it. I think I can give the control back to Sonja so that we can get into the question and answering session if nothing is left.
Yeah, thanks for listening, and I guess we're now.
Should I give the control to you, or like should I keep the control?
No, just stop sharing.
Ah, okay.
So thank you for this talk. It was really interesting. And with that, we say goodbye to our folks on YouTube. Our next talk will be in 2 weeks, and it will be about Fair Agro, another NFDI consortium. So don't miss that. And yeah, goodbye on YouTube.